Hello, in this video we are going to continue what we've talked about with quadratic functions, and we're going to add in some of the new concepts that we've learned that deal with your complex numbers. But in the previous module we already talked about complex numbers. As far as you already know how to find the vertex, you already know how to determine if it's going to open up or down. We know how to find the y-intercept, the x-intercepts, maximum or minimum values of the function. We also know how to do intervals of increase or decrease, and we've talked about the axis of symmetry. All right, so this problem that we're doing now is just sort of a recap that allows us to review some of those previous concepts and talk about something new here. So if you look at your function that's given, we know that's in transformation form, so we can pick out the vertex pretty easily. And just remember that with transformation form, you can always use that h and that k value to get the vertex. And so in this particular example, our h value is 3 and our k is -10. So that makes our vertex 3, -10. Our y-intercept is given as the point 0, 8. And we can find that by plugging in a 0 to the function. And we've done that in previous work this semester. Excuse me. So let's go ahead and start plotting some points down here. Let's see. So 1, 2, 3, 1, 2, 3, and then I'm going to mark this as -10 down here. So my vertex is 3, -10, and my y-intercept is the point 0, 8. All right, so that's going to be way up here somewhere. I'll just say mark that with 8 and put a point there. Okay, we could find our x-intercepts here if we did the quadratic formula. Okay, we could find those if it was asking for those. And our axis of symmetry is going to be x equals 3, because remember it always uses that x value of the vertex. So we can imagine this line coming right through the vertex. And then let's sketch in the parabola, because we have our vertex and we have this y-intercept. And remember, make it kind of a U shape. It's kind of hard to do on this really slippery thing I have to use here. Don't make it look like a V, make it look like a U. Okay, so something like that. Okay. And what they're talking about down here is how you can use the axis of symmetry to help you get more points. Okay, so what we have here is the axis of symmetry of x equals 3, and then we know 0, 8 is a point. This is the y-intercept, and that is 3 units to the left of that axis of symmetry. Okay, so we can go the other direction to find a new point. Okay, so what they're saying is we have 3 units from this axis of symmetry to the y-intercept, so I can go 3 units the other way and identify another point. Okay, so just remember that this x value down here was 3. Okay, and if you go 3 the other direction, you're basically doing 3 plus 3, so that's going to get you to 6, and it's going to have that same y value of 8 as what you have on that y-intercept. Okay, so the point they're looking for right here is 6, 8, and basically you're just using that symmetry of the parabola to get more points very quickly. Okay, so if we keep going down here, it says evaluate f of 5. Well, f of 5 is going to be when you plug in a 5 into the function. So it's going to be 2 times 5 minus 3 squared minus 10. And then simplify that down, you're going to get -2. So that gives us the point 5, -2. So if we go back up to our graph here, we imagine going to the right 5 and down 2, we'd be somewhere right in here. Okay, and that is 2 units away, right? 2 units away from the axis of symmetry. So if I go 2 units the other direction, I would have a point there, and that would be the point 1, -2. Let's see if 1, -2. And just think about how far you're working away from that axis of symmetry and what point. So if you're struggling to understand these numbers here, I suggest getting some graph paper out and sketching this all on graph paper, because it's a lot clearer and easier to see when you have the graph grid there to look at, okay? So this was all pretty much review, except for these concepts down here that might have been new to you, but we've already talked about quadratics and how to find all of this information and graph the quadratic and that kind of stuff. So now we're going to take what we've learned about our complex numbers and build that into what we already know about quadratics. All right, so they're giving us a function here. It says determine the vertex. So the vertex is going to come from the h and the k, and I need to use a -1 for my h and a -3 for the k. It says, does the parabola open upward or downward? It's going to be downward because the a value, all right, the a value is negative. Write the equation of the axis of symmetry. That's going to be x equals -1 because you use the x value of the vertex. Determine the y-intercept, plug in a 0, and simplify, and you get -5. So my y-intercept is the point 0, -5. It says convert to standard form here, okay? So we've done this in our previous module, and remember, you just basically simplify all this algebra out. So you've got to use your FOIL here, and then you need to distribute the 2. And then combine like terms here at the end. So I'm going to go up here where I have a little more room. So it'll be -2x squared minus 4x minus 5. And that is our standard form of f of x, okay, which is what they were looking for there. All right, so then part F, it says determine all real and non-real root zeros of the function by using the quadratic formula. So this is a degree 2, okay? This quadratic has a degree of 2, which means we have 2 zeros. Okay, we have 2 zeros. However, we've discussed in a previous video, we're now starting to see that sometimes we have real zeros. Okay, it could be real, and sometimes we're going to have non-real zeros. And that's our complex numbers, those imaginary numbers that we've discussed. So if you think about how this graph looks, let's go ahead on down to the graph here. Okay, and plot that vertex, which is -1, -3, and plot your y-intercept, which is 0, -5, and think about that axis of symmetry that's coming through there. And we know it opens downward, and so you can see this right side pretty clearly, right? You're gonna have a parabola going down like that, and on the left side here, you would have a point at -2, -5, which is using the symmetry that we talked about in the previous problem. All right, and so you can see here that you're not going to have any x-intercepts, okay? So just by graphing the function and visualizing what's going on there, we can see that we're not going to have any real number zeros. So by understanding the graph, we now know that we're going to be looking for these non-real zeros, okay? So let's go back up here and do this quadratic formula. So you're going to plug in your a, your b, and your c, and you're going to have negative of -4 plus or minus square root of -4 squared minus 4 times a times c, get my negative sign in there, all over 2a. Okay, and I am just using the values from, obviously, from the standard form, just to back up a little bit there. Okay, the a value is -2, the b is -4, and the c is -5. All right, we're just plugging those into the quadratic formula. And then we do some simplifying. So this is 4 plus or minus, and then you want to calculate the inside of your root here, which gives you -24. On the bottom we have -4. Now, as we've already discussed, when you have the negative sign inside that root, you're going to have an I. Okay, so we already know we're going to have an I involved, and we can go ahead and bring that I out, and we can drop that negative off of the 24 as long as we bring the I out. And then we need to do some simplifying here. Well, you have to simplify your square root of 24. I'll come down here. So you can think 2 times 12, 2 times 6, okay, and 2 times 3. And anytime you have that pair of numbers like you're seeing here, that means you have a perfect square factor, okay? And so I can think of this as the square root. Let's see, I'll just try to write it here where I have a little extra room. The square root of 4 times the square root of 6. Okay, and you're getting the 6, you can think of the 2 times 3 gives you a 6. And then square root of 4 is 2, of course, and then you get square root of 6. So we can say 4 plus or minus 2i on the square root of 6 all over -4. All right, let me move this down just a little bit here. There we go. Okay, now when you have this right here, okay, we have to keep simplifying. We have dealt with the I, and that's all good, but we also have a negative in the bottom, which we don't want to leave a negative in the denominator, and we also have a common factor of 2. Okay, so I have a common factor of 2 in these 3 places, which means I can divide a 2 out and to simplify. Okay, so I'm going to come down here. So that's going to be 2 plus or minus I on the square root of 6 all over -2, and that's just dividing that 2 out. Remember, don't touch the 6. It's inside the root. You can't do that. And then lastly, we want to deal with the negative sign. Okay, so you have a negative here, and when I divide that out, it's going to flip the signs throughout the whole problem. Okay, so we're going to have -2 plus or minus I on the square root of 6 over +2. Okay, and that, okay, that right there is the outcome of where we are finding our non-real zeros. Okay, so back to up here, we ended up with these non-real root zeros, all right? And we have found both of them. Remember the plus and the minus, that represents 2 separate answers. Okay, so that reinforces, right, reinforces what we talked about here with the no x-intercepts, because when you have those i's and that answer there, they're not going to be actual x-intercepts on the graph. Okay, so let's just finish this problem out here. It says determine maximum, and the maximum value is -3, and it occurs at an x value of -1, but the actual maximum of the function is that value of -3, that y value. And then here's just some little review. It says state the interval where the function is increasing and decreasing. So increasing is going to be -infinity to -1, and decreasing is going to be the -1 to infinity. Remember, you use those x values. The increasing is going to be the left side of the graph, all right, and the decreasing is going to be the right side of the graph. Okay, and that is review. So I hope you're starting to see some of these concepts come together now, right? We had to learn about those complex numbers, which allows us to do all this simplifying and understand how to do our algebra there. We've talked about the graphs and how things work with the quadratics, and now I hope you're understanding these complex numbers and how they relate to the graph. And then we're also bringing in some review concepts, so you're starting to see a lot of ideas connect together. So just keep working on these, ask questions when you have them, and I'll see you online.